Section 14D, question number 1 from page 354. We're given a function that we need to analyze a couple points for. So here is the horizontal line that goes through y equals 3, and so the question asks us to find f of 2. Well, since it's a horizontal line, the y value of f of 2 is going to be the same as the y value of f of 4, or f of 0, or f of negative 1, etc. So the y value, which is f of 2, the function evaluated at x equals 2, is going to be 3. When we look at the rate of change, or the derivative function, f prime of 2, well, the rate of change, or the derivative function, is the rate at which y is changing with respect to x. Well, I see that y is not changing at all with respect to x, so f prime of 2 will be the same as f prime of 3, or f prime of 0, or f prime of negative 3. So that is going to be the same all the way along. The rate of change of y with respect to 2, or with respect to x, sorry, at x equals 2 is going to be 0. When we look at question number 2, here's the function given here, y-intercept of 4, the x-intercept of 4, f of 0, so the function evaluated when x equals 0, we can plainly see that that is 4. And when we look at the f prime, or the rate of change of this function, the rate of change is defined as delta y over delta x, which is the y-coordinate of 0.2 minus the y-coordinate of 0.1 divided by the x-coordinate of 0.2 minus the x-coordinate of 0.1. And so we can just substitute in values. So the y-coordinate of 0.2, I'll use this as 0.2, so that's 4. The x-coordinate of 0.2 is 0. And then the y-coordinate of 0.1 is 0. And the x-coordinate of 0.1 is 4. So when we do that subtraction, we get 4 over negative 4, which gives you negative 1. So f prime of 0 is going to be negative 1, because anywhere along this line, because it is a line and the rate of change does not change, or the inclination or the gradient does not change anywhere along that line, the rate of change anywhere along that line will be the same. So f prime of 0, sorry, I'm pointing to something you can't see, f prime of 0 is going to be negative 1, just like f prime of 1, f prime of 2, f prime of 4. Anywhere along that line, the rate of change will be negative 1, or the derivative function at any value of x will be negative 1. So in this case, f prime of 0 is negative 1. Now if we scoot on over to question number 3, the function now is a quadratic. It's opening down, cuts through x-axis in 2 places here. We want to find f of 2. Well, f of 2, I believe, when I look at the function, I didn't, I'm just sort of estimating here. F of 2 is going to be 3, because it looks like it's halfway between 1 and 5. Maybe not from my sketch, but in the diagram in the book, that's the way it looks. So f of 2 is halfway between 1 and 5. So we'll be able to say that f of 2 is 3. Then we look at f prime of 2, the rate of change of that tangent, or the gradient of that tangent at the point where x equals 2. The rate of change of the gradient is going to be the same as the rate of change, or the gradient of the curve at that point of tangency at x equals 2. So f prime of 2, I can use the tangent line to solve that, again by using the same technique of delta y over delta x. So y2 minus y1, so I can say 5 minus 1 over 4 minus 0 gives me 4 over 4, which gives me 1. So the rate of change, or the gradient of this tangent line, is 1. Therefore, at the point of tangency, this curve has a gradient of 1 as well.